Hello kids, in today's class we are going to start with the area of triangle. So we know that what is area of triangle? Area of triangle, area of a triangle is equal to half of base multiply with height. That means if we have any triangle here where this one is the base of triangle represented with B and this is the height of the triangle. So area is half multiplied by the base and then the height of a triangle. Okay, so this is how we write the area of a triangle. Now what is given here is draw a rectangle on a piece of paper and draw one of its diagonal. So this is one rectangle and then we have drawn the diagonal. Cut the rectangle along that diagonal and get two triangles. So if we cut it, we will get two triangles like this. Check whether the two triangles overlap with each other exactly. Do they have same area? So yes, if we will do this activity, you will see that these two triangles, they will overlap each other and also they will have the same area. Okay, because they are two equal halves of a rectangle. Now, can you try this with more rectangles having different dimensions? You can check this for a square as well. So even if we will do this activity for a square, we will see the same thing. Because if you see here, this is the complete area and we are dividing this complete area into two equal halves, and these two equal halves, they are in the shape of rectangle here. So can you draw any inferences from this exercise? Please write it here. So what we can say here is, yes, the area of two triangles combined here will be equal to area of rectangle or square taken. Rectangle or square taken. That is from which we have cut these two rectangles. Now, if we will see this here, can you see some relationship between the blue rectangle, this one, and the yellow triangles and their area? Yes, same thing. That is the area. I'm writing again here, the area of one triangle is half of area of rectangle here. Okay, and again the area of two triangles combined, if we just combine the area of two triangles here, that will be equal to the area of rectangle from which they have been cut. Okay, so this is the inference we get it from these two shapes and this activity. Now use your understanding from the previous grades to calculate the area of any closed figure using the grid paper. So kids, if you remember, we have done this in grade 4, 5 and now in 6th same. What we have a square and square sheet, this one, and we are given any shape. What we have to do, we have to find the area of the shape. So in the first one, find the area of the blue triangle BAD. This is the triangle BAD, right? And here each square represent one unit again. So if we see this one, if we see this triangle, what we have here is, you can take it as, you can do it in two ways. Okay, the first way here is, if you see this complete figure, the complete rectangle ABCD, then this triangle BAD is the half of this complete rectangle. So one way to do it is, find the area of rectangle and half it. Half of it will give us the area of this triangle. Okay, so this is the first way. Let's do it by this way first. Area of rectangle, pardon my handwriting, of rectangle ABCD is equal to what? Length into breadth. Length is 1, 2, 3, 4, 5. 5 units. and width is 1, 2, 3, 4, 4 units. That is 20 units. Area of this rectangle is 20 units. Also, area of triangle, we represent the triangle with the sign this. Triangle BAD is equal to half of the area of rectangle ABCD, that is half of 20, which will give us 20 units as the answer. So I'm writing here as 20 units. This is one way. Second way to do the same thing here is that we know that area of a triangle is half into base into height. So half is as is. Let us see the base. 1, 2, 3, 4, 5, which is 5, and height. Height is 1, 2, 3, 4, which is 4. This is, if you solve it again, this will give us the same thing. So since we know the formula and we know how to do it using the graph also, so we can pick up any method to find it. Okay, so this is how we can do. Now second, find the area of red triangle ABE. So this is the red triangle ABE. I'm writing here now area of triangle ABE. Simple, I'm using the formula half into base into height. Base of this is again the same, 1, 2, 3, 4, 5, and height is again the same only. See, 1, 2, 3, 4, again 4 squares. So the area is also same. It is also 10 units only. I'm writing 10 units, or in fact its area, it's 10 square units. Now, both the red and blue triangles have the same area, but they look very different. Area of rectangle ABCD, this complete we took out, it is 20 units. So you can write it as 20 square units. I'm also correcting here, 20 square units. Now, we know the area of rectangle, the full rectangle, and the two triangles given. Moving further, so the area of triangle BAD is half of the ABCD. This also we have derived out. Now, look at the area of triangle ABE. So kids, if you look at this triangle ABE, where we have find out the area is 10 units. But if you see here that this triangle is combination of two triangles. This triangle first, okay, and the another triangle, this one, right? This whole triangle is sum of this triangle and this triangle. That is, it is sum of AE, AEF and BEF. Same thing has written here, AEF and BEF. And if you see triangle AEF, it is half of this rectangle AFDE, right? And this one, the smaller BEF, it is half of this rectangle BCEF. Okay, so these two triangles are themselves the half of these two rectangles. So that means we can write that area of ABE is sum of equivalent of half of these two rectangles. This here, okay, and this is equal to half of the total. That means this is equal to half of the total one, which we have also derived out here. Okay, so what is the conclusion here? So here we can say that area of triangle ABE is also equal to half of rectangle ABCD. Why? Because if you see these two rectangles, the half of these two rectangles, right? The sum of these two rectangles is the complete one. So half is half of the sum of these two rectangles is half of the complete triangle, complete ABCD. So this is equal to half of complete 120, which is also equivalent to 10 square units. The same thing we have derived here. Okay, so we are taking out the same thing here. So I hope this is clear, kids, what we have done for the inner triangle. It is sum of these two, and these two are the half of this green and this red. So if we combined green and red, this will make the total ABCD. That means this complete triangle is half of the complete rectangle also. Okay, and same things we have also calculated here. Now moving next, find the areas of figure below by dividing them into rectangles and triangles. So Kids, I'm just picking one of these because same things we have done earlier also. I am just drawing a line here. This will become one triangle. Same, I'm making it here. This will also become one triangle. So I can see in the first figure, we have two triangles and one rectangle, right? So this I'm marking as first, this I'm marking as not inside, I'm marking it outside as second, and this I'm marking as third figure. So first plus second plus third. What is the area of first figure? Let us see. It is triangle first. So for triangle, first I'm writing it as this. First, second and third area. For the first one, we have half into base into height. Okay. So half into base into height. This is 1, 2, 3, 4 and 1 unit here. Okay. This is for first figure. Coming to second figure, what we have? We have a rectangle. So length into breadth will be the area. Let us find out the length. 1, 2, 3, 4, 5. This is the length. And what is the width? Width is this. So 1, 2, 3, 4. This is the width, 4. This is for the inner rectangle. Now coming to the third triangle, which is this one. This is half into base, 1 into height. What is this one? Again 1, 2, 3, 4. Now just the normal calculation. This is 2. From here we are getting 2. Here we are getting 20, and here also again we are getting 2. So if we combine all these, we will get answer as 24 square units. This is the combined area. Okay. Similar to this, we have B. I'm just breaking and you can calculate it. Okay. This is figure 1. Take it as figure 1. Figure 2. Or again, I'm just writing it outside. Otherwise, we may skip a square. 1, 2, and 3. Do it same way. Similarly here, we can take it as first figure. We can take this one as the second figure and this one as the third figure. So kids, if you see it, can we take it as a rectangle? This one, because this is not a rectangle. I think we'll have to again do it further. See, this is figure 1. I'm taking this as 1 straight away. I'm taking this as 2 straight away. Now for 3, just make it like this. Because the length and breadth of the opposite sides should be same. So just mark it like this. Sorry, wait. So this way you can break it 1, 2, third and fourth figure. Similarly, if you break this one, we have 1, 2, and this is the complete third. And if you see here, we have 1 and 2. So just find out the area using the squares and add them. Simple. Okay. So let us move next